All right, and last but certainly not least, we have Chris with Music Matcher, which is a social application of data from Spotify.
Hello, I'm Chris. My project is Music Matcher. So the way we're listening to music now is changing fairly rapidly. In the past, you can see that streaming music was very uncommon, but it is growing exponentially in the recent years. And during those same years, out of the two major streaming services, which are Spotify and Apple Music, Spotify is clearly winning the race, and they are growing much quicker than Apple Music is. So if you look at just this year, people under 30, how they're listening to music, you can see that the vast majority of them are streaming music now and not listening to radio, which is how people were digesting music in the past. And the way that people are discovering new music is still radio and friends. So what we're seeing here is a change in how people are digesting music, but not a change in how people are discovering music. So what I aimed to do was kind of marry those two trends and take advantage of the fact that people are streaming music now, but they still value that human connection, and they still want people to kind of recommend new music to them. So to complete this project, I used the Spotify API, Pandas and NUMpy for data processing, and Surprise, which is a scikit-learn library that specializes in prediction algorithms. And finally, for my front end, I used React, Bootstrap, and JavaScript. So what data will be used? I don't ask for a lot of data. I know people value their data. So the only data I will ask for is your recently played music. So it'll pop up on the Spotify website when you log in, and it will ask you, is it okay if this website accesses your recently played music on Spotify? And you hit yes, and that is all I will be getting. So pretty much the pipeline here is the Spotify API sends the data to my backend, which is in Python, and then it sends it to Music Matcher website. So a little bit about the backend, because that's where most of the magic happens. So you take the recently played, which is given directly from Spotify. The way that Spotify gives you this data is, or one of the ways, is that you can access your favorite artists during 3 periods of time, one of them being a short period of time, medium, and long. So I take that data and I apply set theory, which you can see with these Venn diagrams. The A and the B and the C would represent short period of time, medium period of time, and long period. And then depending on which artist ends up where on the Venn diagram, they're assigned different weights of how important that artist is to you. For example, if the artist is in both your long-term favorites and your medium-term favorites, it would mean that this is someone that you listen to for a long time, and he's one of your all-time favorite artists, so he would receive a higher rating in the system. So from there, I use Pandas to create a data frame of only the unique artists that were returned and the ratings that I generated based on the set theory. And now that database is sent to, that data frame is sent to MongoDB for storage. And then now that the data has been pre-processed, to actually match users and to match users together with similar music taste, we request that same data frame from MongoDB, and we do something called matrix SVD, which is singular value decomposition. Essentially what that is in the same way that you can factor an equation that is x squared into 2 x values, a big matrix you can factor and figure out the missing values much the same way. And then from there we are left with 2 of these, they're vectors, but you can just think of them as big lists of favorite artists that are in common with both users. So both user has the same list, and values are predicted to fill in the artists that one user has listened to but the other user has not. So there are no 0 values. And then from there, we apply cosine similarity, which is pretty much just looks at the two lists of artists and their ratings, and it determines how similar these two users are with music taste. And then from there, it matches you with users that have very similar music tastes to yourself. So we'll do the demo. Okay. So the way I do this is I actually don't store any passwords at all. So you log in through the Spotify API. So all that's required is your Spotify username, which I have a family plan, so mine's automatically generated. That's my Spotify username. So you submit, and then it will redirect you to the dashboard, which is kind of just a visualization of your favorite artists. So this is top 25 favorite artists as computed by my algorithm. This is my own data. So that's just like a visualization. From there, you can go to user profile, which again, I don't actually store any of this data. This data is all from the Spotify API and is loaded live when you load the web page. So it is your username, your email, the name you have for your Spotify, and also this URL, which if you go to it, is your public profile on Spotify. So this is any playlist you may have. So if you're recommended to someone, you can put in their link and see what kind of public playlist they have and what kind of music they listen to. And this is your Spotify picture that's loaded. And finally, the part that happens behind the scenes is a friends list. I wasn't able to get that many friends for some technical reasons, but I do have my sister and 3 of my friends from home. And this is after feeding it through the algorithm. These were the similarity scores. They're between 0 and 1, 1 being a perfect match, 0 being these two people couldn't be any less similar in music taste. And so you can see, okay, if I wanted to find some new music, EJB Green, he's a pretty close match to me. It'd probably be a good idea. I can message him and we can start talking about music and giving each other recommendations. And that's my project. I don't have a slide for it, but in the future, I want to add like messaging functionality within the website. So if you're matched up with a user, then you can immediately start a conversation with them and kind of talk about music and match. And then beyond that, once you add a friend, maybe like a news feed of saying, like your friends list will be comprised completely of people who have similar music taste, and you can make posts about like, hey, this is someone I'm listening to now, they're pretty good, and it'll just pop up on your news feed of the things your friends are recommending. So that's it. You guys have any questions? Yeah, please.
I'm over 30.
Okay.
I do want to match my music list the same way you do. And, you know, I really liked your app because I listen to a lot of music. It's kind of, I want someone to like have similar music taste that I have.
Right.
I'm just trying to find like other things. They may have listened to somebody or an artist I haven't heard from yet. So that's why I like, and I'm
Exactly.
So I would love to use your
Yeah, definitely.
It's really good.
Thank you. Yes.
So first off, no shame on the sister being on there. My sister has amazing music taste. So these vectors you're finding the cosine between to get similarity. Like how many dimensions are going on in these vectors? I guess that.
It is the total amount of unique artists that are returned by Spotify between you and the person you're matching with. So for me, my personal vector was 86 artists, but when you combine it with somebody else, the number of unique artists that they have that you don't will also be added on. So theoretically, it could be 120, 100, somewhere around there, probably. Yeah?
What was the decision for you to use MongoDB?
Just because I didn't, the way I was storing data was